welcome back to the Common Lisp video series I'm doing here. First off, I apologise for the lack of content recently. I was quite unwell for several weeks. Not sure what it was, but it wasn't fun. And just as I was starting to recover, I accidentally injured myself, so I've been kind of out of it for a couple of weeks, but I'm feeling better now, so we will continue with this. And I call this a Common Lisp video series. It's more what my channel is really about now. This is Common Lisp, but no matter. Where we left off last time, however, was we were finishing off this Turing machine, and we had three missing functions here. We had the not equal, the less than, and the less than equal to. However, there is something I need to discuss. There is a mistake in the if-else. This was doing some stuff here with the num. This was incorrect, so I have since corrected this. So if you are following along at home or work or wherever, please do make sure that you have corrected this if-else instruction here, because the full program that we're going to write at the end of this video is not going to work correctly, because there is a bug in that instruction there. So bugs in compilers and interpreters happen. Case in point, I put one in there. It wasn't deliberate, and it has been driving me mad for the past 2 hours, but I have found it. So please do make sure that you have corrected that and put the correct structure in place there. But with that said, we're going to have a look at implementing the not equal, the less than, and the less than equal to, which I imagine are pretty trivial for you because we already have examples of them. So we're just going to get rid of that, and we're going to bring this wee guy down. And we're going to wrap this in a knot. There we go, so that's our not equal. And with regards to our less than, we're going to copy this one. Invert the sign. And it's the same with our less than equal to here, so we're just going to copy this wee guy. And of course, once again, we'll reverse the sign there. I thought that looked a little out of alignment there. There we go. So that is the missing components required to implement a working compiler here, or an interpreter. And as you can see on the right, I was doing a lot of stuff here, a lot of debugging, and that's how I found the bug in this bit here. But now that we have all these things in place, I'm just going to get rid of some of our stuff here. We don't need this anymore. And what we're actually going to do is we're going to have a look at this fella here, but first we're just going to check to make sure that our not equals works. So what is our not equal? 302. We're just going to check these because we put this test code in place, so we do want to make sure that we are using our test code. So we're going to make sure that the value stored in 2 is not equal to the value stored in 2. And we're going to store that in 3. So this should be 302, not 301. This should be a 302. Should be a 302.2200. And there we go, we can see in the bottom left that is a 302.2200. Now we're also going to say we're not going to have the value of 2 and 3, and we're going to store that in 2. So this should be 302 to 120 212. Yes, so we can see that again in the bottom left that is working as expected. Do I have some output? Oh yeah, I've got something left over there, so I'm just going to get rid of that and recompile, because we have this stuff coming out here, which is not what I was expecting. It's just leftover debug code. So we've got our not equal here. We did test our 303s and our 304s, so we're really just going to test our 305s and our 306s, our less than and our less than equal to. So we've got our less than here, so we're going to check that the value in 2, which is 1, is less than the value stored in 3, which is 3 itself. And we are going to store that in 3, so this should evaluate as 3052110. So let's just make sure that's doing what we expect. 2110, and it is, and that's great. So we're going to change that comment with 305. To apologize that my comments are not all up to date, and sorry about that. So what we want to do is want to check that the value stored in 1, which is 1, is less than or equal to the value stored in 2, which it is. I'm going to store that in 3. So we should get 3051210, which is, so that less than is working as we would expect. So let's do one more. What we want to say is the value stored in 3 is less than the value stored in 2, and we're going to store that in 3, so this should be, if I'm right, this should be 3053200. Yeah, so it's saying here that the value stored in 3, which is 3, is less than the value stored in 2, which it isn't, so that final 3, that 323 becomes 320 because it is not true. So we can see that our less than is working as expected. So let's move on to our less than or equal to. So we have our less than or equal to here. We're going to have 3061130. So the value stored in 1 is less than or equal to the value stored in 1, and we're going to store that value in 3. So this should be 3061110, which it is. So that works as anticipated. And so here we're going to check that the value stored in 3 is less than or equal to the value stored in 2, which should be false. So we should see 3063200, which we do. So that's great. We've got all of these working here. We've tested all of our 10 series all the way through to 106. We've tested our 201s. We've got our 202s working now, which we thought they were, but they weren't. So we've got all this in place now. What we really need to look at is I need to change this because this isn't quite right. So let's break this down. This is a complete program, and this is kind of what we've been building towards over these last few weeks, and again I apologize about the break and leaving you hanging there. This is a computer program that is in effect just going to loop, decrement and exit. So we're going to have if statements, increments, kind of like function blocks. Well, we don't have functions here, but it is going to behave in a Turing complete manner, albeit very simply, but it is going to loop and exit when a certain condition is met. So what we have here is we've got our unconditional jump, which is our 201, and we're going to jump immediately to 5. So no matter what the output this program is, 205 is just going to jump there. Then we've got 0, 10, 0, and really we've got this 301 at position 5, so we're just jumping straight ahead to 301. And 301 is an equality operator, so we're just going to check to see that the value stored in 2, which is 0, is the same as value stored in 3, which is 10, and we're going to write that value to 4, which is 0. So here, 0 and 10 are not equal, so 0 is written then. Although we've already got a 0 there, this chunk of code here will update that value to 0 for us. Then we're going to check the value stored in 4, which is that. And because we've got the simple if check, basically if it's 1, it'll jump to one address. If it's 0, it'll jump to the other. So if the value stored in 4 is 1, we're going to jump to address 13, which is 0. So that means when we reach that 0 and start executing, 0 is our exit code, so that is our return 0. We're done here. However, if the value stored in 4 is not 1, that is it's 0, we're going to jump to 14 to 105, and 105 is our incrementer, so we're going to increment the value in 2, which is, well, this 0, so that becomes a 1. And we're going to jump unconditionally to position 5, so we're going to jump back to that 301. We're going to check that the value stored in 2, which is now 1, is the same as the value stored in 3, which they're not, so that stays 0. So then we check if that's 0 or 1, and then we jump to 13 or 14 accordingly. But because this is a 0, we jump to 14, we increment the value stored in 2, which is currently 1, so that increments to 2, and so on, and we do that back and forth until the value stored in 2 becomes 10, and then that 301 check then says actually the values stored in 2 and 3 are equal, so write 1 into that 4th position. So what we would expect here is a 201, 5, 10, 10, 1, 301, 2, 3, 4, 202, 4, 13, 14, 0, 105, 2, 201, 5, 0. Fingers crossed that I've got this correct, because I'm very tired and still a little bit sick. So this has not looped infinitely, so that's great. Let's get rid of my debug code there. Let's get rid of that and recompile that. Save that. There we go. So we've got this value in the bottom left, of course. So we started off with 201, 5, 0, 10, 0, 301, 2, 3, 4, 202, 413, 14, 0, 105, 2, 201, 5, and 0. And we were expecting 201, 5, 10, 10, 1, 301, 2, 3, 4, 202, 4, 13, 14, 0, 105, 2, 201, 5, and 0. And looking here, we have 201, 5, 10, 10, 1, 301, 2, 3, 4, 202, 4, 13, 14, 0, 105, 2, 201, 5, and 0. So this has actually worked. We can see that this program has modified itself, but all of the things that Alan Turing posited and said that were required for a complete program are here. We have checks, we have the ability to move to a new point in the program and go back and forth through the program, so we can use these go-tos and checks. And although there is no explicit loop construct here in our code, these checks with the go-tos allow us to work around that limitation just by jumping backwards and forwards. So it's not really recursive. We don't really have a stack in the traditional sense. We just have a list that we're moving across, forward and backwards, checking things and updating things, and eventually, if the program is written correctly, and it is a little bit brain bending to get into this frame of mind, I do appreciate that, but once you've got there, you can eventually terminate once a certain condition has been met. So I know that was a rather short video, but I hope you enjoyed it. Again, I apologize on my lack of content recently, but I'm glad to be back. I'm glad to be working on these. I think I've not decided yet on what we're going to look at next. But I think perhaps object orientation in Common Lisp might be the next interesting subject. And for anyone that was interested, nobody actually built a game for my competition, which fair enough. You weren't under any obligation to do so. So what I might do is I might still buy a copy of Land of Lisp, because I still want to thank every single one of you that are watching. And I'll just pick. We'll come up with a poll or some way, and somebody will get a copy of that book, because it's fantastic. I have a lot of fun reading it, and I genuinely do appreciate all of you. So take care, everyone. Don't get sick, don't fall in the shower, you know, any of those things that have happened to me recently. And I will see you in the next video.